Welcome to the DIY Honda Garage channel. The Honda CR-V 2023 Plus may experience a diagnostic trouble code, DTC P0190-17, which corresponds to a fuel rail pressure sensor circuit high voltage issue. This indicates that the output voltage from the fuel rail pressure sensor is higher than expected, leading the powertrain control module, PCM, to identify it as an abnormality. The fuel rail pressure sensor is critical as it monitors the fuel pressure within the rail, ensuring optimal engine performance. It is typically located integrated with the fuel rail assembly in the vehicle's engine compartment. Understanding the functions and positions of relevant components is essential when diagnosing this DTC, and appropriate troubleshooting steps must be followed to rectify the issue efficiently. The DTC P0190-17 indicates that the fuel rail pressure sensor output voltage has exceeded a predetermined threshold, signaling potential issues in the fuel pressure readings. This abnormal voltage can occur due to various factors, interfering with the PCM's ability to accurately assess and control fuel delivery to the engine. Located integrated with the fuel rail pressure sensor plays a vital role in ensuring proper fuel pressure, which is essential for efficient engine combustion and performance. The PCM, or Powertrain Control Module, interprets this sensor's readings to manage fuel injectors and maintain optimal engine conditions. Therefore, any irregularities can lead to performance issues and must be addressed promptly. The potential causes for DTC P0190-17 can include several components leading to a high sensor output voltage. A faulty fuel rail pressure sensor may fail to provide accurate data, causing the PCM to receive incorrect voltage readings. Additionally, issues within the external circuit, such as damaged wiring or poor connections, may also contribute to heightened sensor voltage. The PCM itself could be malfunctioning, misinterpreting the data due to either internal faults or connections to the sensors. Diagnosing the problem necessitates segmenting the system into parts and checking each component methodically to isolate the root cause of the DTC. The symptoms associated with DTC P0190-17 may manifest through various observable problems, primarily affecting the vehicle's performance. Drivers may notice poor engine performance, such as stalling, hesitation, or reduced acceleration, stemming from irregular fuel supply. The check engine light will typically illuminate as the PCM detects the abnormal sensor voltage, alerting the driver to a potential issue. Erratic fuel delivery could also be experienced, posing risks of engine misfires or irregular idling. Recognizing these symptoms early can help prevent further complications that might arise from neglected fuel system issues. The first step in troubleshooting DTC P0190-17 involves turning the vehicle's ignition to the on mode. This action prepares the vehicle's electronic systems to initiate a diagnostic check. After waiting for 2 seconds, the next action is to check the HDS, or Honda Diagnostic System, specifically monitoring the fuel pressure converted from PF sensor voltage reading. If this voltage exceeds the threshold of 4.89 volts, it indicates that the failure can be replicated and is a sign that further diagnostics are needed on the fuel rail pressure sensor or associated circuitry. It is crucial to perform this step accurately to ensure proper identification of the problem area. In the second troubleshooting step, disconnect the fuel rail pressure sensor connector to begin an inspection of the sensor's functionality. Using a jumper wire, connect terminals number 1 and number 2 on the connector. This bypass allows for a direct assessment of the sensor circuit's performance while isolating the sensor itself. Subsequently, turn the vehicle back to the on mode and monitor the HDS reading for the fuel pressure converted from PF sensor voltage. A normal condition should show a value less than 4.89 volts, which indicates that the sensor may be malfunctioning if the reading is abnormal. Understanding these steps is essential for accurately diagnosing the overall fuel delivery system. The third troubleshooting step involves checking for any open wires in the fuel rail pressure sensor circuit, especially focusing on the PF signal. This inspection must be performed with both the fuel rail pressure sensor and the PCM connector disconnected. Set the ignition to IG mode and use a multimeter to check continuity and resistance. A normal reading indicates less than 1 ohm, confirming that the wiring is intact. If you find higher resistance or an open circuit, it points to issues within the wiring harness, which could be leading to high voltage outputs and well beyond expected levels. Regularly checking wiring is crucial to maintaining effective communication between components. Following the open wire inspection for the PF signal, the next crucial step is to check the SG1 signal's open wire condition. Similar to previous inspections, this must also occur with the fuel sensor and PCM connector disconnected. Set the vehicle to the IG mode and check for continuity on the SG1 pin. The expected outcome here is again less than 1 ohm, indicating no breaks or malfunctions in the signal wire, ensuring proper ground connection. If the results deviate from this standard, it suggests a potential wiring issue that should be thoroughly investigated before concluding on other components. These steps are part of a logical flow to narrow down the issue step by step. The final step in the troubleshooting process is to inspect the powertrain control module, or PCM. If the previous inspections indicated normal conditions for both the fuel rail pressure sensor and wiring, it likely points to the PCM as the underlying issue. To confirm, ensure that all PCM connectors are secure and free of corrosion or damage that could interfere with signals. If physical checks render no faults, conducting diagnostic tests on the PCM would be the next course of action. A faulty PCM can lead to incorrect readings and thus incorrect fuel management, which should be addressed to restore proper vehicle operation. Understanding the PCM's crucial role in regulating engine and fuel system functionalities is vital during this step. After completing all troubleshooting steps, it is essential to verify that all DTCs related to T0190-17 have been cleared. Use the Honda Diagnostics system to ensure that no faults remain in the system. Once cleared, conduct a performance test of the vehicle, ensuring that it accelerates smoothly and operates without stalling or hesitation. Observing the fuel delivery system during driving conditions can confirm that the previous issues have been resolved effectively. If all systems are operational and meet the parameters, it indicates a successful repair. Continuous monitoring after component repairs is essential to ensure that the vehicle performs optimally. Though no specific preventive maintenance steps are mentioned for DTC P0190-17, general practices can help ensure the fuel system's longevity. Regularly checking the fuel rail pressure sensor's conditions can preemptively identify any potential issues that could lead to high voltage output. Furthermore, consistent inspections of the wiring harness for any wear, fraying, or corrosion can help maintain optimal sensor communication with the PCM. Routine DTC clearing and inspections can also help catch any emerging problems early, preventing costly repairs in the future. Establishing a maintenance schedule that includes these practices is advisable for vehicle longevity and reliability. In conclusion, addressing the DTC P0190-17 related to fuel rail pressure sensor circuit high voltage involves a systematic approach to troubleshooting. Key components, such as the fuel rail pressure sensor, PCM, and wiring, are pivotal in diagnosing the issue effectively. Proper inspection and reparation can increase vehicle reliability and performance. Monitoring the fuel sensor status regularly will help detect early signs of malfunction, which can prevent more severe engine performance problems. Understanding the roles of the PCM and sensors within the fuel system reinforces the importance of accurate diagnostics. Ultimately, early detection and resolution are crucial in maintaining the vehicle's health and efficiency. Please like and subscribe to the channel. See you next time.